Here we are again in the last section of this chapter. I'm pretty excited, hopefully you are too, but kind of sad. Sad at the same time. Anyway, in the last section we saw how to graph quadratic functions. But remember, they had this special form. It looked like this, where it was a times x minus h parentheses squared plus k. So the problems that we're going to be given in this section, they don't have quite that nice form. They don't look quite the same. So in this section, in order to graph them, what we're going to do is, like it says here, we're going to complete the square so that the equation is of this form. And then we'll be able to graph it. You know what I should say is the function, not equation here. This should say function. There we go. And then once we have it in that form, then we can go back to the previous section and graph it the exact same way. But I think maybe off to the right side here, I'm going to write kind of step by step on how do you do this. So let's see. To do this, I would say first thing you want to do is, let's see, if the coefficient of x squared is not 1, factor it out of the variable terms. So the first couple problems we'll deal with, we won't have that to worry about, but the later ones we will have to worry about that, and that'll be the first thing you'll want to do. The next step is to find just like with completing the square, the magic number. And remember, it's half the coefficient of x squared. Remember, so I'm calling it b this time because remember, the number in front of x we usually call b. So we're going to, what next? Add this number inside the parentheses, I guess if you factored something out, or to the right of bx, then subtract this number on the right side of the function. Although I have to point something out for the more complicated problems, keep in mind that if you had factored something out, or, I'm going to say, if you had done step 1, like you had to do that, you added more than just the magic number. And we'll see what we mean by this. So you must subtract this actual value. Okay. And then the last step is complete the square inside the parentheses. Or, I'm not even going to say that, I'm just going to say factor. Factor the first 3 terms at this point. And I'll say into, now it should look like we saw in the last section, a times x minus h squared plus k. And then you'll be ready to graph it like we've seen, in the previous sections. Alright. So I have that off to the side. You know what? Since that's kind of right next to part B, even though it seems silly to start with part B and then go to part A, just because it's right next to it, I'm going to do part B first, because I don't think it's much harder. Okay, so step 1 says, if the coefficient of x squared is not 1, then you're going to have to factor it out of the variable terms, which by that I mean just the first 2 terms, because they're the only ones that have an x. But our coefficient of x squared is 1, so there's no need for us to do that. I'm just going to maybe just rewrite the whole thing. Alright, so we can skip step 1, the coefficient of x squared is 1. Now we're going to find that magic number. Alright, if you can do that off to the side, that'd be great. We have half of b, our b is negative 10 squared. Okay, that's half of negative 10, that's negative 5, squared is 25. There we go. That's what we want to do. And then, like it says, that was step 2. We're done with that. We're going to add this number inside the parentheses. Like if you had to do step 1, then there should be parentheses right now. But if there are no parentheses like ours, because we didn't have to do step 1, we're going to add it to the right of bx. So we just wrote bx, that's 10x, so we're going to add 25. And then there's a plus 21 that was already there. But then to balance it out, because I can't just add things to whatever I want, by adding 25 I changed it. But to balance it out, now I'm going to subtract this number on the right side of the function. So I added 25, now I'm going to subtract 25. So I didn't really do anything. I made it look a little different by adding 25 and then subtracting 25. But if you think about combining those guys, 25 and negative 25 is 0. So I made it look different, but I didn't really change the value of this function. Okay, and then all the rest of that step 3 is kind of just for if you had factored something out, and we haven't. So we don't really have to worry about that. That'll be for future problems. So we can move on to the last step. It says, factor the first 3 terms. So these guys should factor into a perfect square. So I'll ignore the 21 and the negative 25 at the end. That guy, it actually does, right? Because if you factor that, you're thinking, okay, that's x minus, I don't know, what multiplies to 25 but adds up to negative 10? Negative 5 and negative 5. And then you can combine the terms on the right. The 21 and the negative 25 make negative 24. And since those two factors are the same, I'm going to write it as x minus 5 squared minus 4. So all this work, it kind of makes you appreciate the last section, how every problem started like this, you know? We didn't really have to do this. So it was really, but someone had done this for us, so that was nice of them. But now that we have it in this form, now we're ready to do like we did in previous sections. I'm going to go the vertex, or the previous section said, okay, the vertex is, remember h is the number inside the parentheses with x, but you change the sign, so it'll be positive 5, and then k is the number at the end, adding or subtracting, and you don't change the sign. So there's 5, negative 4, and then the axis of symmetry, that's the line x equals the x value of the vertex. Since there's a positive number in front of the parentheses there, I'm going to say it's opening upward. And then I need one more thing. I just need to figure out one more point. So I'm going to plug in, you know, something close to this x value of the vertex. So maybe 4? It doesn't really matter. You can plug in 3 or 6 or something like that. Alright, so g of 4 is going to be, if I replace that x with the 4 there, let's see. Let me simplify that guy. That's 4 minus 5 is negative 1 squared minus 4. But negative 1 squared is positive 1. Minus 4 is negative 3. So that point, the x value is 4 and the y value is negative 3. There we go. Let me plot that vertex now. The vertex was 5, negative 4. That's down here. And the point I just found, 4, negative 3, is down here. So they're pretty close together. And then the axis of symmetry is the line x equals 5 right through that vertex. And if I connect those dots, it looks like it's going to open upward, which is good because that's what we kind of thought. It's kind of hard to tell how wide this thing's going to be. I think I maybe made it too wide. Just trying to make it sort of curve upward. And the way it's curving upward from those 2 points to each other, kind of can tell how it's going to curve from there, I guess. I don't know, just kind of round it out. And I'm going to try to make the right side look like a mirror image of that. Something, oh, well, close enough, close enough. You know. Alright, so that's the idea. It's just completing the square until it looks like it's in the same form as the previous section's problems. And once it's there, then it's something we know how to do because we saw it already in the previous section. Let's try part A now. Part A, it's going to be similar. The first step was you want to see if there's something you have to factor out, but the coefficient of x squared is 1, so there's nothing I need to factor out. I can move on to the next step, which was completing the square, or sorry, finding the magic number. That'll be half of the coefficient of x is 4 squared. So let's see, half of 4 is 2, and I square that, and I'll get 4 back again. Alright, so as it says, you're going to rewrite this guy. It's x squared plus 4x, but after the 4x, I'm going to add the magic number. So I'm going to leave some space there. You're adding 4 here, but then to balance it out, you're subtracting 4 there. And that way, the whole point, I guess, of subtracting 4 is because you don't want to change this function. You want to make it look different, but not really change the function itself. And that's why we kind of inserted something and then took it away again in the end. So we didn't really change it. And now the first 3 terms should factor into a perfect square. And if you kind of remember when we did completing the square, we know this is going to look like x plus or minus something squared. And remember that something is going to be half the coefficient of x, or half of b. So if you just look at your b there, b is 4, half of 4 is 2. Or it's, remember, the halfway point of over here when you calculate the magic number? So that's a faster way to do it. And then the last 2 terms I can combine to make a 1. Alright, that's looking good. So that wasn't too bad, right? Now we're going to identify the vertex. I change the sign of the x value so it becomes -2. But I don't change the sign of the y value, it'll stay +1. And then the axis of symmetry, it's x equals the x value of the vertex, -2. And this one's going to open up because the number in front of x right here, when I factored it into a perfect square, the coefficient of the parentheses is a positive number, so it's opening upward. Alright, now we just need one more point, and then we're going to be able to graph this guy. I'm going to plug in anything that's close to the vertex x value. Well, it's -2. I like a 0. That's pretty close, and it's a nice number. Oops, so this is f of x. And I'm going to plug it into the nicer one that I just simplified it into. X plus 2 squared plus 1. But I want to plug a 0 in there. 0, 0. Alright, then I'll simplify this guy. That's 0 plus 2, that's 2 squared plus 1. 2 squared is 4, plus 1 is 5. Okay. That point must be 0, 5, because I plugged the 0 in for x. Now I think I'm ready to graph this guy. So the vertex was -2, 1. There he is. And then the point I just found was 0, 5. That's up here. Let me draw the axis of symmetry, the vertical line right through the vertex. And it looks like it should open up, huh, if I connect those 2 dots, and that's exactly what we said above. Let me connect those dots and then try to kind of extend it, keep going. Now I'll try to make the left side look like a mirror image of that guy. Sure. The base doesn't look very round, huh? It's supposed to be more round, like a U shape, not a V shape, but whatever. You know, what are you going to do? Looks good to me. Alright. So far so good, right? Let's try part C. We're trying to make them get a little bit more difficult every time. Build it up kind of to the hardest ones. Okay, part C. Now, and this one again, because the coefficient of x squared is 1, we don't need to do the first step. We're just going to go ahead and skip to step 2. We're going to calculate the magic number. That's half of b squared. Okay, b is 3 this time though, so this is kind of a bummer. Half of 3 is not pretty, and remember from completing the square section you do not want a decimal. So don't say half of 3 is 1.5 because it won't be pretty. I'm going to put the 3 over 1 and multiply across. That'll be 3 over 2, and then we're squaring that. 3 squared is 9, 2 squared is 4. So there's our magic number. That's pretty ugly. But we want to rewrite the first 2 terms, and then right after that we're going to add that magic number 9/4. And then that third term, -10. And then to balance out the 9/4 that you added, you're going to subtract that guy. And that way you didn't really change this thing. You just made it look a little different. You didn't change the value of it. And the first 3 terms should factor into a perfect square. This is where I'm glad I remember that what goes in here, remember, is half of the coefficient of x, which is the number you found halfway through the magic number thing. Before you squared, we had 3 halves there. And let me combine these guys. Ugh. I got 10 minus 9/4. I have to put that 10 over 1 and find a common denominator. So I'll have to multiply that guy by 4. So that'll be, if you want to, you can kind of show it off to the side. That's -40 over 4 minus 9 over 4, which will make -49 over 4. Ugh. That's not pretty. Alright, so that's it. There's our function. That's pretty bad, huh? H of x is that terrible thing. X plus 3 halves squared minus 49/4. Ugh. Oh well. Okay, so that guy, what's his vertex? The x value will be the opposite sign, -3 halves, and then the same sign, negative 49/4. The axis of symmetry is x equals the number, that's the x value of the vertex. You know what, if you want, okay, at this point, or when we're closer to graphing, it's up to you. I would think about, I'm going to have to plot this point. How am I going to plot that point when it's fractions, you know? I mean, I think if the homework problem asked you what is the vertex, they're going to want you to give them fractions, but more practically, if you were trying to graph this, you're probably going to want to make those decimals or mixed numbers. So if I can go divide the bottom into the top here, like 2 divides into 3 once with 1 left over, so that's negative 1.5, which is a lot nicer. And then something similar for 49/4. I'm going to divide that 4 into 49. It goes in 12 times, so it's negative 12, and the remainder is 1, so it's negative 12 and 1/4, the old denominator. That's going to be a lot easier to plot, so I can just tell this is just a little lower than negative 12, and this is a little to the left of negative 1. And that way also the axis of symmetry is going to be at negative 1.5 as well. It's kind of nicer. And then looking back, let's see, once I factored this into a nice form, there was no number in front of the parentheses, so that means a, the value of a is 1, which means it's opening upward. Alright, and the last step is just to find one more point. So I'm going to try to plug in something close to the x value of the vertex. It doesn't really matter. Even though the vertex is a fraction, I don't want to plug in a fraction. I'm going to choose something, maybe like 0, that's fine. Okay. It doesn't matter if you plug in negative 2 or negative 1 or positive 1. I mean, anything that's somewhat close, maybe within 3 units away. 4 maybe, if you're lucky, it might be still on the grid. The 0 is fairly close, so I think I'm going to try that. And I'm going to plug it into the highlighted form of the equation, excuse me, because it's going to be a lot prettier. It's f of, is it f? Oh no, h, sorry, they called this guy h. H for Henry or something. H of x is this thing, but I'm replacing h with 0. Wait, what am I plugging? Yeah, 0. Alright, I don't like all these fractions, but you know, 0 always makes everything better than it was going to be otherwise, so maybe this will be alright. So we got 0 plus 3 halves, that's 3 halves, squared, minus 49/4. Okay, 3 halves squared, that's 9/4. At least these have like denominators. 9 minus 49 is negative 40/4. Hey! That's negative 10! Hey! Yay, yay, yay! So it's a nice point. The x value was 0, and the y value is negative 10. Alright. So even though the vertex was ugly, at least that point's nice. So I realized too that I don't really have enough room on this graph for these points, but you know, whenever you see that, just like if this is, you're on an exam and you kind of want a point that's further down, feel free to extend this thing further. Left, right, up, down, whatever you need. Don't feel like this is all you can do. You can't make it longer. Yeah, because what was our vertex here? It was, well, we had it in one form first. It was pretty bad, but then we made it mixed numbers, which is a lot better. Negative 1.5 is going to be about here. And then down 12 and a little extra. This is negative 10, negative 11, negative 12. So probably about here somewhere. Somewhere around there. As long as it's in the ballpark, don't worry about it. And then what was the, yeah, that was the vertex. The second point that we found was 0, negative 10. It's pretty close. It's right here. There we go. And the axis of symmetry should be going right through that vertex. Directly through that guy. Okay. If I connect those dots and I keep the graph going off to the right, it's going to be an upward parabola, but I think that's what we said, so that's good. Try to make the left side look like a mirror image as best I can. Ugh. Well, you know, pretty good, I guess. Close enough. Whew, alright. Pretty good, I guess, huh? So, it's a little extra on top of what we did before, but it's a little, yeah, a little, not too bad. So let's see, we're halfway through. These are getting tougher, though, so let's try part F. And notice this one, the coefficient of x squared is not 1 finally. So we have to do step 1 that we wrote above. Negative 1. Aha. So step 1 said, if the coefficient of x squared is not 1, even negative 1 is different. So I do have to do step 1 but I said factor it out. So it'll be a negative 1 and then parentheses. But notice that the directions said just factor it out of the variable terms. So I'm going to factor a negative 1 out of the first two terms, but not the 7. He's not in part of the factoring. Yeah, if you remember, we said that up here. Where'd it go? Yeah. Factor it, not out of all the terms, but only the variable terms. You know why? Because this is, what I kind of think of these problems is, how I think of them, is this thing could factor into a perfect square. If only the 7 were not a 7. If it was something, if it was some specific number, there's one perfect number out there that'll make this factor into a perfect square, but it's not 7. So we're kind of like throwing the 7 off to the side and trying to figure out what that perfect number would be if I could find it, you know? That's why you don't really want to involve the 7. It's kind of his fault that this thing isn't factoring very nicely. So okay, if I factor a negative 1 out of the first term, positive x squared is left. If I factor a negative 1 out of the second term, a positive 2x is left. Alright, so far so good. And then the next step is to find the magic number. So think about it off to the side here. Magic number is half of the coefficient of x, so b, which is 2, squared. And notice I'm looking at b as it is now, not how it was before. I'm not going to go half of negative 2 is blah, blah, blah. It's half of the new b value that I have now. So half of 2, that's 1, squared is 1. That's sort of a nice magic number, right? Okay, now the next step, like it says, you want to be careful here. This is the first time we've had to do all this. Like it says, I'm going to add the magic number inside the parentheses with the variable guys, but I'm supposed to put something at the end to balance it out. Okay, so I need something here that'll balance out the equation. So I have to ask myself, what will balance the equation out? So before what we did was we said, well look, here I'm adding 1, so here I'll subtract 1. But you know what you really did? You put a 1 in the parentheses. Think about, what if you distribute this negative 1 back in here? I'm going to write this down, but we don't want to really do this, just so you can kind of see what's going on. Where'd it go? If I were to distribute that negative 1, it'll be negative x squared minus 2x minus 1, and then the plus 7. So really, if you want to balance this guy out, it looks like a 1 the way I wrote it, but it's actually a negative 1 in disguise because it's being multiplied by the negative 1 out there. So really, to balance it out, you'd have to actually add 1 at the end, because these are opposites. So really, if you had to factor something out in the first step, you can't just add something and then subtract it. You have to really think, the thing I added there is a 1, yeah, but I put it in parentheses, so it's being multiplied by the negative 1. The opposite of a negative 1 is a positive 1. So if you ever want to check, did I actually balance it out right, multiply everything out so there's no parentheses, you know, get rid of the thing you factored out by distributing and make sure that they're opposites. So right now, if you were to distribute that negative 1 back in, like we said, you'd see this guy times this guy as a negative 1, and this would balance that out. If I have a negative 1 here and a positive 1 there, those add up to 0. So just kind of trying to figure out, if I were to undo the factoring at this point, I guess what's the opposite of that, you know? If I undid this factoring, then I really put a negative 1 in there, not a positive 1. The opposite of that is a positive 1. So you got to be really careful. You're just really trying to balance this out. Because yeah, if let's say I had put, not thinking, I had put a minus 1 here, thinking that was balancing it out because I see a plus here and a minus there. Then this is like we talked about before, the scales, you know, if you have scales that are balanced, if I put a 1 on one side and a negative 1 on the other, they wouldn't be balanced anymore. One side would be heavier than the other. And that's because the plus 1 that I thought it was a plus 1, but it's really a minus 1, because I put it in the parentheses, which means it needs to be multiplied by the outer number. Anyway, so that was kind of a long, too much explanation, sorry. And now what's inside the parentheses should be able to be factored into a perfect square. Remember, that number that goes in there is half of this thing. Half the coefficient of x is 1, because half of 2 is 1. And we can combine the last two guys. 7 and negative 1 is 6. So there it is. That's pretty much it. If you wanted to, if you see the negative 1 in the front multiplying and you say, that kind of looks silly, you can just make it negative without the 1 there. It's up to you though. You can leave the 1 or write it without the 1. Alright, but now I think we're finally ready to identify the vertex and all that stuff to graph it. So this guy's vertex is negative 1, because you change his sign, keep the sign of 6. That means the axis of symmetry is going to be x equals, well, why did I put parentheses? X equals -1. This thing's going to open down because the number in front of x squared, the value of a, is -1, so it's negative. Now we just need one more value. Let me plug in something for x. Something close to -1. How about 0? I love 0. That guy's my favorite. It's okay. F of x, is it? They call it f, or which one's this guy? Yeah, this is f of x. Is this thing, so I'll plug it in there. F of x is -x plus 1 squared plus 6. But where the x was, I want to put a 0. Alright, that's -1 squared plus 6. But notice since the negative's outside the parentheses, you're not squaring the negative, so it's still a -1. It's not like it was -1 squared like that. That would be different. The negative's outside the parentheses, so it doesn't get squared. That means it stays negative. -1 plus 6 is 5. That point will be 0, 5. Alright, we got 2 points. I think we're ready to graph. So first, the vertex was -1, 6. Where's that guy? Right about here. The other point we found was 0, 5, very close by. And then the axis of symmetry is the vertical line right through the vertex, x equals -1. There we go. Let me connect the dots and try to round it out on the right side. Let's see. Go, sure, why not? So we kind of know what the right side looks like. The left side, not so much, but at least we know that it's a mirror image of the right side. Sure. Something like that. You know, don't worry about being perfect. It's not about that. Alright, let's try part E. I think this one will be more complicated because the last one we had to factor a -1 out, which is fairly close to 1. This time, though, we have to factor a 2 out. Yeah, this is another one where we have to factor something out because they said if the coefficient of x is not a 1, but remember, you only factor it out of the first 2 terms. The last guy, again, remember, the way I think of it to remind myself I don't factor it out of the third term is it's all this guy's fault that this can't be factored into a perfect square. If he was the perfect number, there's one number out there that he could be that would make this factor into a perfect square, then I wouldn't even need to do all this stuff with magic numbers and stuff. But it's all his fault. It's not the same. Now, if I take a 2 out of the first term, I'm left with x squared. If I take it out of the second term, I'm left with 8x. You know, if you're thinking, wait, you can factor a 2 out, but you can also factor an x out, that kind of defeats the purpose. You don't want to factor an x out, because what you're trying to do is make this look like x squared, you know, x squared plus bx plus c. You don't want to factor an x out, even though you can, you don't want to. It's kind of, I don't know, not really part of the problem, or not really what you want to do. Now we need that magic number. Alright. Half of the coefficient of x, that's half of 8, and then we'll square that. Half of 8 is 4. If I square 4, I get 16. That must be the magic number. Alright, this is where I got to be really careful. I'm going to rewrite what we have, 2 times x squared plus 8x, and then I'm leaving some space because I know I'm adding the magic number in there. It was 16. So the magic number will always be exactly what goes here. It's the thing that you have to add or subtract at the end that you're not sure. So you're thinking, right now, what will balance that out? Will balance the 16 out, you know? But think about it, if you put a 16 inside the parentheses, what you added is not really 16, it's 2 times 16. Because if you were to distribute, this kind of, in my mind, I think of it as, if I distribute this, it's 2x squared plus 16x plus 32. So then if I think about it that way, what do I have to add here or subtract here to balance it out? A negative 32. There we go. So this is kind of all happening in my head or in my scratch work. You don't really want this in your problem. And that's kind of how you can think of what will balance it out, is just distribute that number back in now that you have your magic number there. If it's adding, subtract that same number, you know. If it's a plus 32, put a minus 32. If this was a minus, I'll put a plus. Just whatever's happening, do the opposite. And now I think I'm ready to move on. What's inside the parentheses should factor into a perfect square. The number inside will be half of the coefficient of x. Half of 8 is 4, so that must be a 4. And then the numbers at the end, the 23 and the negative 32 add up to negative 9. So there it is. This function g of x can now be written oops, yeah, whatever, as 2 times x plus 4 squared minus 9. There we go. Whew, and now we're home free. Now it's just like in the previous section. The vertex of this guy, change the sign of 4, that's negative 4. Keep the sign of negative 9. The axis of symmetry is going to be x equals the x value of the vertex. This thing will open up because the coefficient of x, or the coefficient of the parentheses, is positive. Now I just need one more point, and I want to plug in something close to the x value of the vertex. So I don't know, maybe negative 2. It's up to you. You could have done negative 1, or you could do negative 3, or negative 5, negative 6, whatever. You can maybe try 0. Maybe. Sometimes that's on the grid, but it might be off the grid, so be careful. You don't want to go too far from the x value of the vertex. Let's see, though. Let me rewrite our function g of x. Oops. Once we had it in the nice form, it was 2 times x plus 4 squared minus 9. But I'm replacing my x's with negative 2. Alright, let me see. Negative 2, negative 2. And of course, you want to, when you simplify the right side of this, you want to use order of operations. So better focus on what's in parentheses first. Negative 2 and 4 makes 2. Exponent next, 2 squared is 4. And then multiplying next, 8. 8 minus 9 is negative 1. There it is. So that point must be the x value I plugged in, negative 2, comma, negative 1 is the value I just put in. Whew! Alright, we're almost home free with this one. So my vertex was negative 4, negative 9. Ooh, that's way down here. Way the heck down there. And the point I just found, negative 2, negative 1, is up here, pretty high up. My axis of symmetry is going right through the vertex there. Alright, and I think this is going to open upward, which, yeah, we've mentioned earlier it should. That's good. If I connect those dots and kind of keep extending that graph, looks pretty narrow, I guess. Maybe I made it look too narrow, but whatever. I'll try to make the left side look similar. That looks good. Sure. Why not? Alright, looks good. We got one more, and I think this will probably help it sink in. This is pretty tough stuff, because, yeah, you have to really think back to completing the square, which you probably tried to block out of your brain because it was so painful. But here it is, coming back to haunt us, unfortunately. Well, let's try h of x here on part F. Yep, and of course, since this is the last problem, it's probably going to be the hardest one. I don't know, maybe. But since the coefficient of x squared is not a 1, we're going to have to factor its coefficient out. But remember, you only factor it out of the first two terms. The last guy, the constant term, is shoved off to the side. It's kind of like I said, I always think he's in trouble. It's like, hey, it's all your fault that we can't factor into a perfect square as we are. It's all your fault we have to do all this extra work to find the magic number that'll make us factor into a perfect square. If you were a better person, we could do it all by ourselves. Oh man, now I kind of feel bad for that constant guy. I'm sorry, buddy. Oh well, okay. If I factor a negative 3 out of the first term, x squared is left. Negative 3 times what makes positive 6x? That'd be negative 2x, right? Yeah, negative 3 times negative 2. Okay. Whew. Alright, magic number now. Magic time. I'm hoping that magic number makes it sound more fun than it really is. Does that trick anybody? Anybody? No? Okay. Half of the coefficient of x, half of negative 2 squared. See, half of negative 2, that's negative 1. If you square that guy, you get 1. That's a nice magic number. Come on. Alright, I gotta be careful here. I know that's exactly what goes in the parentheses with these guys. Positive 1. And then, of course, the plus 2 that was already there. I just gotta think, what's gonna balance that guy out at the end? So this is where you might, kind of the thought bubble, what is really happening here? I put a 1 in the parentheses, but when I distribute that 3 in, if you were to put that back in, it'd be negative 3x squared plus 6x minus 3. So how do I balance out a minus 3? You do the opposite and add 3. That must be what I want to do. Aha! So that really helps me to kind of picture it, the number in front distributing, and then I can see what will balance it out. If it's a negative, I'll put a positive of that. If it's a positive, I'll put a negative. So it's weird because it seems like this plus 1 and plus 3 aren't really balancing each other out, but they really are if you were to distribute that number in front of the parentheses. And now what's inside the parentheses should factor into a perfect square. X plus something squared, and the something is half of the coefficient of x. Half of -2 is -1. And then the guys at the end, 2 and 3 can add up to 5. Whew! Alright, so that function, h of x, can be written as -3 times x minus 1 squared plus 5. Whew! Alright, almost done. Now let's find the vertex. It'll be, okay, the x value will be this number but opposite sign, so +1. And then this number, same sign, +5. Axis of symmetry, it's going to be x equals the x value of the vertex 1. Because the number that's the coefficient of the parentheses is negative, it's going to open downward. Yeah, and again, just to remind us, that's because a is -3, which is negative. Just in case you kind of forgot why that is. Alright, now we just need one more point. I'll plug in something close to the x value of the vertex. Ooh, 0's close. I like 0. You can, of course, remember we said you could plug in whatever you want, as long as it's close to that value. Anything close to 1, it could be 2, 3, 4, 0, -1, -2, you know, somewhat close. Alright, it should be h of x equals -3 times x minus 1 squared plus 5. But I want to put a 0 where the x was. Let's see what will happen to that guy. -3 times 0 minus 1 is -1. -1 squared is +1. +1 times -3 is -3. Plus 5 is 2. The second point must be 0, 2. Alright, we almost have it. Now I just have to plug or plot those 2 points. The vertex was 1, 5, that'll be up here. And the point I just found was 0, 2. There he is. Okay, let me draw the axis of symmetry goes right through the vertex. There he is. Let me connect those dots, and it's supposed to open downward, which kind of makes sense. Try to keep that going. Ooh, that got kind of steep. Oh well, it's not really that big a deal, but just kind of try to make it curve the way it's curving. Between those 2 points, it kind of looks like it's curving at a certain rate, you know, falling downward. I kind of picture someone, what if someone threw something, you know, like, I don't know, let me erase what we have. Like the top point is where the object was thrown from, and the second point that we found is some point that we know it hits later. So if it's falling like that, you know it hits that point, then it kind of must fall. Gravity's kind of taking hold of it, so it's not falling to the left as fast. It's kind of slowly, almost becoming a vertical line, but not really. And then the right side should be a mirror image of that, so it'll go wee. Oh god. You know. It's pretty good, right? Pretty good. This is an art class, right guys? Alright, that's pretty much it, so hopefully that made sense. I think we did the hardest part of chapter 11, or you know, this chapter that we're in fairly early in the chapter, so hopefully this wasn't the worst part. But thanks for listening, and I'll talk to you later. Thanks.